Hey everybody, this is Mrs. Sack. I'm going to be going over topic 1, lesson 2 with you, going strong. Let's point out our key terms here. We have qualitative reasoning and quantitative reasoning, and we will be discussing what those mean as we go through this lesson. Our learning goals today are applying qualitative ratio reasoning. Whoop, that's not very pretty, is it? Applying qualitative ratio reasoning to compare ratios in real world and mathematical problems. And then we are going to apply quantitative reasoning. So we're going to do a qualitative reasoning and quantitative reasoning to compare ratios in real world and mathematical problems. And then we're going to compare in order part to part and part to whole ratios represented verbally, pictorially, and numerically. All right, here we go. So I'm going to kind of go through this first part quickly because I know our videos have been a little long, so let's see if we can speed them up a little bit. It says use reasoning to compare the fractions in each pair. Well, I'm going to do it the way that we all need to be practicing this because I know I just got done teaching a lesson in 8th grade and they had to do it this way as well. You need to find common denominators. So we have to find common denominators. So common denominators. And I'm going to abbreviate that. So rather than trying to list our multiples of 7 and list our multiples of 9, I'm just going to multiply 7 and 9 together. So to do that, I'm going to do 7 times 9, and I'm going to get 63. So I know that my denominators are going to be 63. And 7 times 9 is 63, so I also must multiply 6 times 9. What I do to the denominator, I must do to the numerator. 6 times 9 is 54. And then I multiplied this 9 by 7 times 7. So I multiply the 8 times 7. And 8 times 7 is 56. So now I can easily compare and say that 54 is less than 56. So 6 sevenths is less than 8 ninths. My next one I'm going to do in a different color just because it's pretty, right? Why not? All right, let's look at our next one. Our common denominator between 13 and 11. Literally just going to multiply 13 by 11. And when you multiply 13 by 11, you get 143. 143 and 143. If you need to do calculations off to the side here, great. I just knew what that was in my head. So now I have to multiply 7 times 11, and I have to multiply 5 times 13. And I know 7 times 11 is 77. And I know that 5 times 13 is 65. So now I can very easily see that 7/13 is greater than 60, or is greater than 5/11. My final one, 4/5 and 4/3. I don't even have to do any math here. I just should know that 4/3 is not a proper fraction. It's an improper fraction. 4 is greater than 3, so I automatically know that 4/5 is going to be smaller than 4/3. 4/5 is not even 1 whole, and 4/3 is greater than 1 whole. What did we do here? We simply found equivalent ratios. We found equivalent fractions. So if we were to simplify 54/63, we were to simplify that by the greatest common factor, we would end up with 6/7. And if we were to simplify 56/63, 56/63, that's hard to say, we would simplify it and we would get down to 8/9. So we're just making equivalent fractions or equivalent ratios. And that's going to be a really big skill moving forward in this unit and moving forward in math. All right, so we are going to scroll down. That was page 183. We're going to scroll down to page 184 to our getting started. And I'm going to forewarn you a little bit. This is kind of a lot of writing. I'm going to do my very, very best to abbreviate as much as I possibly can. Okay. So if you want to abbreviate as well, that's fine. A lot of this whole lesson I'm going to do is kind of a lot of writing because we are going to be doing we are going to be working on qualitative reasoning. So we're just going to look at something and figure it out without using numbers. So on page 184, let's read. The shaded portion in each glass represents an amount of lemonade. Read each situation and answer the question. And then the big key here, explain your reasoning. We see this on our tests, right? All the time. So we always have to explain our reasoning. So Tammy's glass of lemonade has a weaker tasting lemon flavor than Jen's glass of lemonade. I put a W for it's weak. If you add 1 teaspoon of lemon mix to both Jen and Tammy's glasses, which glass will contain the lemonade with the stronger lemon flavor? So we're looking for a stronger lemon flavor at the end. So we added 1 plus 1 teaspoon to her glass, and we added plus 1 teaspoon to her glass. So which one is going to have the stronger lemon flavor? If you want to pause the video, remember you're writing what I'm writing, so pause me at any time. If you want to pause the video and try to figure it out on your own, that's cool. Do that now. All right, here we go. So if Tammy's glass had a weaker taste to begin with, and we added the exact same amount to each glass, qualitative reasoning tells me that Jen's glass will be stronger. All right, and then explaining our reasoning, I'm going to do that in blue. So I'm going to explain in blue. Why will Jen's glass be stronger? Well, it had a stronger taste to begin with because it was stronger to begin with. It was stronger to start. We'll say start. That's easier to write than begin. It was stronger to start, and the same amount. Sorry, my handwriting isn't as good as usual. The same amount of, is it lemon mix? Yeah, the same amount of mix was added. The same amount of mix was added. So Tammy's glass, you would have had to add more mix to Tammy's glass, right? If you don't understand that, if this doesn't make sense to you, then you need to make note of it. You need to make a note and ask Mr. Christian, Ms. Choquette, or Ms. Sack when you come back to class after watching the video. Now is a good time to pause your video and make sure that you are writing down what I write down, okay? Here we go. Now we have Beth and John. Beth, obviously, just looking at our picture here, Beth obviously has more drink in it than John's glass, right? So Beth has more than John. So let's read what it says. Beth's glass of lemonade has a weaker flavor, so Beth is weaker, than John's glass of lemonade. If you add 2 ounces of water to Beth's glass, so we're adding 2 ounces of water to Beth's glass, and 1 lemon mix, 1 teaspoon of lemon mix to John's glass, which glass will contain the lemonade with the stronger lemon flavor? Well, hers is already weaker. And then you're adding water to it, which dilutes anything. Adding water to any kind of liquid will make it have a weaker taste. So it stands to reason, using our qualitative reasoning, that John's glass is going to be stronger. So John's glass is stronger. John's glass is stronger than Beth's glass. Okay, but we also have to explain our reasoning, right? So we're going to go down here and we're going to explain. I'm going to use blue. John's glass is stronger because he added more lemon. I don't like lemon personally. I think I would rather have hot chocolate because he added more lemon flavor. And Beth added water. So it stands to reason that John's glass is still stronger than Beth's. Again, time to pause if you need to and take notes. Make sure you're writing down what I write down. And I'm going to do Jimmy and Jake. Jimmy and Jake, we know that Jimmy's glass is larger. He has more lemonade or lemon drink in his glass than Jake. Jimmy and Jake have glasses of lemonade that taste the same. So even though Jimmy has more, they taste the same. If you add 1 teaspoon of lemon to each one lemon here and 1 lemon here, that's a number 1 lemon. There we go. Those kind of look like L's, don't they? You don't want that. So 1 lemon to each one. Which glass will have the stronger flavor? And how do you know? This one's a little bit trickier. We're going to talk a little bit about volume. So which one has less volume? Jake has less volume, right? Jimmy's has got more. Jake has less. So it's Jake. So Jake's glass will be stronger, or Jake's glass is stronger because, let's change our color. You don't have to change color, but it helps some people to understand that explain our reasoning part. Is stronger because he had less drink to begin with. He had less to begin with. So there's less water, right? There's less water in Jake's. So it'll have a stronger flavor. And this, friends, is qualitative reasoning. We didn't do any math whatsoever. We just used our logic skills. And that is what qualitative reasoning is. So going back, that is this qualitative reasoning. So this is using words. So let's mark that. Words. So what do you think quantitative is going to be? If you said numbers, you're right. Words and numbers. Okay. So let's keep going because we don't want to have a 40-minute video, do we? Although I know you love listening to me for 40 minutes. All right, we are going to move on to activity 1 on page 185. Qualitative comparison. So qualitative comparisons, we are still using qualitative reasoning. There's my vocab word. When you reason like this, comparing ratios without measuring or counting. So we're not using numbers here. We are just going to use words. We are going to use our logic skills, okay? Please pay attention to these habits of mind. Okay, these are important. You're going to reason abstractly and quantitatively and construct arguments to critique the reasoning of others. That's kind of what we're going to be doing in this lesson. I'm sorry, that's really sloppy. I am not good with this little writing pad yet. I'll get there. All right, so we're going to just choose the correct statement to complete each sentence and explain your reasoning. So again, I'm going to do explaining in blue. We have to explain our reasoning. Math is a lot of explaining if you haven't figured that out yet. If you cannot determine the answer, explain why not. Okay, so let's look at Luke. Luke plans to use 4 more tablespoons of orange mix today than what he used yesterday to make the same amount of orange drink. His orange drink today would have a stronger tasting orange flavor, a weaker tasting orange flavor, or a mix that has the same strength. Okay, well, let's look again. He's adding 4 more tablespoons of what he used than yesterday. So it would have a stronger tasting flavor. You can check mark it, you can circle it, you can put a star by it, whatever floats your boat. Why? Well, why would it have a stronger tasting flavor? We're going to use a word here, and I really want you to make note of this word. You've probably seen it. We are going to use the word ratio on our notes on this page. So that is a very important word. A ratio can look like a fraction, but it is not necessarily a fraction. It is comparing 2 things. What 2 things are we comparing in all of these activity examples? We are comparing orange mix, right, to what? What do you put in your orange mix? Where are you putting it? You're putting it in water, right? You're putting orange mix in water. So we're comparing orange mix to water. So our reasoning is Luke's ratio of orange mix to water, it increased because he added more, and more is another word for increase, right? So there's that keyword of ratio. So we're comparing orange mix to water. We're going to do that for each one of these. If you need to pause the video, pause the video. If you need to rewatch the video, rewatch that part of the video. You can rewind me and listen to my voice again. Here we have Dave and Sandy. Dave and Sandy each make a pitcher of orange drink. Okay, cool. So we've got Sandy's pitcher and Dave's pitcher. Sandy's pitcher is larger than Dave's pitcher. I'm going to draw a picture. So here, and I'm not very good at drawing, so don't forgive me. So there's Dave's, and here's Sandy's. Sandy's is larger than Dave's, right? Sandy's pitcher is larger than Dave's. Sandy uses more orange mix than Dave. Okay. So she has more orange mix than Dave, so hers is bigger. We want to know about Dave's orange drink. That is sloppy. I do apologize. We want to know about Dave's orange drink. Well, do we know anything about Dave's drink? We know it's smaller. Do we know how much water Dave has? Because remember, we're comparing water and orange mix. Do we know how much water Dave has? No. Do we know how much orange mix Dave has? No. All we know is Sandy used more. So we cannot answer this. There's not enough information. Not enough information. Remember, we have to know about orange mix and water. We don't know about either of those for this number 2. So that saves you some writing, right? So if you need to pause, remember you can pause. I'm going to go to number 3. If a race car travels more laps in less time, oh, this one's not orange mix to water. They tricked us. If a race car travels more laps in less time than it did yesterday, its speed would be slower, exactly the same, or faster. Well, I mean, it would definitely be faster. So the speed of the race car would be faster. Why? We're going to use the word ratio. The ratio. And what are we comparing? Laps to time increased. I'm sorry, my handwriting is a little bit sloppy. The ratio of laps to time increased, so we know it is faster. Okay. We are going to move on to writing ratios and comparing them using numbers. We're going to do some quantitative reasoning, okay? So we are going to go to numbers. And I am going to give you a forewarning, the next page. It's a lot of writing, so you might need to get out another sheet of paper and do your work off to the side. If you can write small, write in your margins. That's what I'm going to have to do. So now we're moving to page 186. Pause me at any time, okay? So I'm telling you now, this is a lot, okay? So now we're going to talk about quantitative reasoning. Quantitative reasoning is when you compare ratios by measuring or counting quantities. Quantities are numbers, right? So we're going to use numbers now. Yay, it's math class. Let's use numbers. We got to save writing for ELA. We're still using the same habits of mind, okay? So let's look at this as an example. And yay, we're using hot chocolate. I love a good cup of hot chocolate, especially around this time of year. Yum. So here we go. The 6th grade students are making hot chocolate to sell at the winter carnival. Each homeroom suggested a different recipe. We have homeroom 6A, 6B, 6C, and 6D. If you want, because that's a lot of numbers, you could rename them. 6A is Mr. Christian. 6B is Miss Reyes. 6C is Miss Jones. 6D could be Dr. Thigpen. If that's how you want to think about it, that's fine. But for now, I'm just going to stick with these letters and numbers. We have to compare these. It says use reasoning to determine which recipe we want the strongest chocolate taste. And then we're going to use a different color and we're going to do the weakest chocolate taste. Okay. So we have to figure this out. And this is stuff that we just did at the beginning of our lesson, right? What did we have to do when we compare, whoops, wrong way. What did we have to do when we compared these fractions? We had to make common denominators, right? Guess what we're going to do now? Exactly the same thing. Now, there is something you need to know about making these milk to cocoa powder into fractions. We want to know about the chocolate taste, not the milk taste, right? We don't care how milky this is. We want chocolate. It's called hot chocolate, not hot milk, right? Silly. So we are going to make our chocolate, our cocoa powder is going to be on our numerator. So I'm going to write that up at the top, just so I don't forget. And you have to write them the exact same each way, or you're going to get the answer wrong. So we're going to do cocoa, C-O-C-O-A, over milk. And they try to trick you. They're like Maui, they're tricksters. There's a Disney reference for you from Moana. They put milk on the top, right, in this graphic. So we have to be really careful. So homeroom 6A, the ratio of cocoa to milk for 6A is 3:2 for 6A. The ratio of 6B is 8:5. Cocoa to milk is 4:3 for homeroom 6C, 4:3. And 6D is 7:4. Whoa, so there are multiple ways that you can find common denominators with 4 fractions. We can multiply all of these together. We can multiply all of our denominators together and get one big number, okay? So that would be 2 times 5 is 10. 10 times 4 is 40. And 40 times 3 is 120. So we could do it like that. So you could have everything out of 120. That's a lot for my brain. So I'm just going to compare 2 at a time. Okay, I'm just going to compare 2 at a time, and I'm going to start with 6A and 6B. So it's like a battle, right? I like to think this is like the battle of the homeroom. So we're going to do a battle. So this is round 1. We're going to do 6A versus 6B. And we're going to see just between 6A and 6B who has the stronger chocolate flavor. Okay, and then the winner of that will go on to face off against the winner of 6C and 6D. All right, oops. Sorry if that popped up on your screen. I had a notification. So we have 3/2 and 8/5, right? 3/2 and 8/5. What is our common denominator between 2 and 5? If you said it was 10, you're correct. So we have a common denominator of 10. We know we multiplied 2 times 5, so we have to multiply 3 times 5, and we get 6. No, we don't. What am I talking about? I'm a goof. Sorry, guys. 3 times 5 is not 6. 3 times 5 is, in fact, 15. Woo! It's nap time. All right, so I multiplied 5 times 2 to get 10, so I have to multiply 8 times 2, and I get 16. So I know that 16 is greater than 15. So I know homeroom 6B is the winner of the first battle. So we know homeroom 6A, they don't have the strongest one. Sad day for homeroom 6A. All right, let's do battle number 2. I'm going to do it in green. I love green. All right, red's my favorite color, but I love green too. So let's do 6C. So this is the other battle to see who goes to the finals. 6C versus 6D. So 6C, we had 4/3, versus 7/4. What's the common denominator between 3 and 4? If you said 12, you're correct. And remember, pause me at any time. So I multiply this by 4, so that means I multiply my numerator by 4. 4 times 4 is 16. 4 times 3 is 12, so 7 times 3 is 21. So I know right there that 6D is better than 6C, right? 6D beats 6C. So we have two winners right there. We have 6B and 6D. So now, to find the overall winner, we're going to do 6B versus 6D, and we're going to use blue. So now we're going to do 6. I got to scroll up a little bit, okay? I got to have a little bit more room. All right, we're going to do 6B. So this is the winner. This is our championship. This is our World Series. Okay, we just had the World Series. It just ended a few days ago by the time you watch this video. But we have a new champion in baseball. Like, this is your Super Bowl match right here. This is your NBA final match. Game 7. Here we go. All right, we got 6B because they were the winners of our first battle, and 6D versus, 6D. And you know what I'm going to do? I'm going to use the original ratios for these because they have smaller numbers than 10 and 12. I don't want to figure out common denominator of 10 and 12, but I can do 8 and 4, or excuse me, 5 and 4. So 6B, we had 8/5, and 6D, we have 7/4. If you say the common denominator between these is 20, you are correct. 5 times 4 is 20, so I have to multiply 8 times 4, and I get 32. And 4 times 5 is 20, so I have to multiply 7 times 5, and I get 35. So I know 32 is less than 35, so we have a winner. So the strongest chocolate taste was homeroom 6D. Good job, homeroom 6D. Woohoo, strongest chocolate taste. That's the one I would want to drink, right? But now they want us to find the weakest chocolate taste. And you're thinking, oh my gosh, Miss Sack, I cannot do all this work again. I just went through all this. I don't want to do this again. Well, guess what? You don't have to, right? We know from doing all of our calculations over here, 6A was weaker than 6B, and we know 6C is weaker than 6D. So now we just have to compare the losers of our battle rounds, right? So now for weakest, we're going to compare the losers from the first battle. So we had 3 halves. Oops, let me write this, sorry. Just kidding. We're going to compare the weakest is going to be 6A versus 6C, and see who had the weakest. So 6A was 3 halves. So 3 halves for 6A, and I used that. And I'm going to use 4/3 for 6C. If you said the common denominator is 6, you would be correct. You could also use a common denominator of 12, 24. Any multiples of these that are the same will work, but the 6 is easiest to work with. So I know 2 times 3 is 6, so I have to multiply our numerator by 3. And that would be 9. 3 times 3 is 9. 3 times 2 is 6, so I have to multiply my numerator by 2, and I get 8. So now we want the weakest. So we don't want the biggest fraction. We want the smaller fraction. So the weakest is actually 6C. Weakest is 6C. The weakest flavor is 6C, and the strongest, I should write it better, excuse me. The strongest flavor is 6D. That was a lot. You can do it multiple ways. This is just how my brain works, okay? And my brain is not your brain, but that's okay. You guys could do it another way. Like I said, you could find you could have multiplied all your denominators together and found one large common denominator. But this is how my brain has to do it. So Part B, it says, show how you used ratio reasoning to order the recipes. Identify the ratios you used as part to part and part to whole. Okay, so let's put these in order from strongest to weakest. Well, we don't have to do that. We just need to say, how did we do this? How did we use ratio reasoning to do this? Well, we found common denominators. So first, I found common denominators, right? You found common denominators. ORS. I found common denominators between the classes, then compared numerators. The winners faced off, right? The winners faced off against each other. The winners faced off for the strongest. We are not doing part C. We're not doing part C, so I'm just going to keep writing. The winners faced off for the strongest flavor. The losers, or the smaller ERS, or the smaller fraction, okay? The losers faced off for the weaker flavor. This is a lot of writing. I understand that. My hand hurts too. But that is what we did. That is all we need to do. We do not need to show, right? Because we already did it. You already did all your work. And then it says, identify the ratios that you used as part to part or part to whole. So did we use part to part ratios or part to whole ratios? For every single one was the same. All of our ratios were part to part. So I'm going to answer that right here. All ratios were part to part, P2P, okay? Part to part. Because whole would have meant we added up all of the milk, okay? So we added up all the milk, so 2 plus 5 plus 3 plus 4, we would add up and use that number. But instead, we broke it up. So it was part to part, not part to whole. So we are stopping there. We are not moving on today. Well, with my video anyway. I hope you guys learned something. I hope that your hand isn't falling off. And I hope that you come to class prepared to ask questions and work a little bit more with quantitative reasoning, finding those common denominators, okay? I will see you all in class. Bye.